First one we have 120/70. There's two ways to do this one. The first way is to say, well, this must be 60 degrees because they're 180. Or you could have remembered that these are remote interior angles, and remote interior angles I always add together to give you your exterior angle. So you could have also done x plus 70 equals 120, which would give you x equals 50. However you do it, you should have came up with x equals 50. All right, for our next one, number 2, it says measure of angle 1 equals 35 degrees. So this would be 35 degrees. Since we do have an isosceles triangle where the base angles would be congruent, that means 1 would also be 35 degrees. Well, that's going to be 35 plus 35 is 70. That leaves 110 degrees left over for that angle. ADB must be 110 degrees, which must mean that 3 is going to be 70 degrees because they equal 180. ADB plus BDC is going to equal 180. This is an isosceles triangle, so 4 and 5 must be congruent. Once again, 4 and 5 must be congruent. If those two are congruent, we have an angle at 70. We have 110 left over to split between the two, so each of those must be 55 degrees. Well, they asked for the measure of ABC, which would be 2 plus 5. Angle 2 is 35, 5 is 55. 35 plus 55, last time I checked, was 90 degrees. So this one should come out to 90 degrees, which would have been A. Questions on that? Okay, then let's go over questions from the homework. There should be questions because there are several of you that didn't have stuff finished or didn't have the correct answers to. So what questions do we have? Labib.
Can we do 28?
We can. We sure can. 28. 28 says we have an equilateral triangle DEF. Hey, guys, if you're not sure how to do something, draw a picture. I can give you points for drawing a picture. That's correct. Even if you don't do anything after it, if you draw a picture, it shows me that you're thinking about something and you're doing correct stuff. So let's go ahead and draw that triangle. So we have an equilateral triangle. That doesn't look equilateral, but it is. Call it DEF. It says measure of angle D equals x plus y and E equals 2x minus y. So just remember, an equilateral triangle, you're thinking all of the sides are congruent, all of the angles are congruent, but more importantly, all of your angles are 60 degrees. So that's 60 degrees, that's 60 degrees, that's 60 degrees. So in this case, they say that the measure of angle D equals x plus y. So D is x plus y, and E is 2x minus y. Here's the thing. Generally speaking, you generally need two different equations to solve because I have an x value and a y value, so we need a system of equation. So there's a couple things we could do. We could go x plus y equals 60 degrees and 2x minus y equals 60 degrees. That would be two equations. We could also do x plus y equals 2x minus y. That would also work. That would be three equations you can pull from this. You just need to pick two of them. Does that make sense? You just need two of those possible equations. So on the answer key, I believe I picked them both equaling 60. So I did x plus y equals 60 degrees. And I picked 2x minus y equals 60 degrees. Those are two things you can pull out of there. Remember, you could pull out the third one. That is x plus y equals 2x minus y. You just need two. So in this case, we actually already have a zero pair. I don't know why I did extra work. We already have a zero pair. We can actually add these together. So I did an extra step in my answer guide for some reason. Note the plus x and minus y. A zero pair are going to be the same value in front. One's positive, one's negative. Currently we have that, so I can go ahead and just add those together. So that's 3x, that's 0, equals 120. That is where you got your x equals 40. And Labib, I believe you had x equals 40 on yours, right?
Yeah.
All right, to get my y value, all I do is take that x equals 40 and plug it in to either one of the equations.
Yeah.
40 plus what equals 60? Y must be 20.
All right.
Is that good?
Yeah.
Yeah, it's a good problem to go over because all three of these were you have to come up with two equations and then use elimination or substitution to solve for it. All right, other questions? Yeah. 25 and 29. Which one's your better? What's 25? Oh, 25 A?
Yeah.
So the big thing about 25A, I wonder if I have it up here. I do. Good. 25A. I bet you had no problem getting a measure of angle 1, right?
Yeah.
Because it's 23. And then you probably said 2 was 23, correct? And then what did you say 3 was?
And 3 was 124.
I believe it should be 134.
Oh, yeah.
Yeah, 134. Oh, yeah, I'm the same way. That's why I said I think mine is 134. All right, here was the trick to this problem. See this line in blue and that line in blue? They say they're parallel, which must mean we have to use it to get down to the lower angle.
Oh, so 4
Is
got it.
same side interior, right? So they add to 180. So 4 would be 46. But you're good from there?
Mm-hmm.
Cool. And then you said 29, right?
Yeah.
Which I'm okay doing that because I'm sure several of you have the same question on 29. 29 says you have a triangle JKL. So let's draw that triangle JKL such that JK is congruent to KL. So I'm going to draw that triangle. I'm going to name it JKL. And JK is congruent to KL. So without looking any further, I know that angle J is congruent to angle L. That's without, guess what? You get points for that picture, just recognizing that. All right, now we'll put the rest of the information in. It says that J equals 2x minus y. So this one is 2x minus y. We have measure of angle K is 2x plus 2y. I promise that's an x. It just kind of got mixed up. All right, and our L is x plus 2y. Since I have all these x's and y's, I need two equations so I can use substitution or elimination. I can use systems of equations. So I need two equations. The first one that's jumping out to me, angle J and angle L have to be equal to each other. So my equation number 1 is set J equal to L. By using those letters, we are going to use 2x minus y equals x plus 2y. That is kind of my equation 1. But I need a second equation. Now, these don't necessarily equal 60 because it's not equilateral, so I can't use that one. But what I can reach back to is, if I add all the angles in a triangle, what does it equal, degrees-wise? What was that? 180. It equals 180. So if I do J plus L plus K, it should equal 180 degrees. So that's going to be my second equation. My equation 2 is just going to be angle 1 is 2x minus 1, or y, plus 2x plus 2y plus x plus 2y equals 180 degrees. Maybe I'll put some parentheses so I can denote where these came from. That is just angle J plus angle K plus angle L. Now you just simplify those so that the x's and y's are on the same side. So we have 2x minus y, we have x plus 2y. So I subtract x from both sides. That'll give me x minus 3y equals 0 for the top equation. Our bottom one, I have 2x plus x, which should be 5x. And I have negative y plus 2y, so that's 4y minus 1y, which would equal 3y. We actually have a 0 pair already. Once again, I don't know why in my notes I decided to adjust stuff, but we have a 0 pair already. So we can add these together because negative 3y plus 3y is going to equal 0. 5x plus x equals 6x equals 180. 180 divided by 6 is going to equal 30, so x equals 30. And you'd take that 30 and maybe plug it in for that x there to come up with y equals 10. All right, so these problems aren't bad as long as you recognize you need two equations and how to get those two equations. Other questions on the homework? Yeah, question. 24B? Real quick, any questions on this? Was it that bad when I went over it, or did it make a lot more sense? Just two equations. Just two equations. On the test, if you get confused, just think to yourself, okay, I just need two equations. I just need two equations. Did you say 24B? Okay. 24B is, what if 1 is k? So we set 1 equal to k. That means 2 is equal to k, which means this third angle here is 180 minus k minus k. In other words, 180 minus 2k. Is that good so far? Okay. Well, to get to 3 and this angle here are a linear pair. They add to 180. So to get this value, I have to do 180 minus angle D. So it'd be 180 minus whatever we get out here. Well, I can't get anything out of it, so I have to leave it in that form. So 3 is going to be 180 minus whatever the other side of D is, would be ADB, which is going to be 180 minus 2k. Well, we can actually simplify that. We can simplify that to just being, remember when you distribute this negative sign? We would have 180 minus 180 plus 2k. 180 minus 180, those would cancel out, and we'd just be left with 2k. So 3 is just 2k. Well, to get my other two angles, we know all together they add to 180. So 5 plus 4 plus 3 equals 180. What would be the easiest way to put this? Do I leave it like I did, or? All right. So, first of all, we have 180 minus 2k left. So whatever this is, say this is 30 degrees. We would have 180 minus 30. I'd have 150 left for these two angles because they have to be congruent. Does that make sense? All right. So we're going to do 180 minus 2k, and then we're going to divide it by 2 because I have two angles to actually distribute it to. I have this one and that one. Doing that math, you're going to come up with 90 minus k. So 4 is going to be 90 minus k. 5 is going to be 90 minus k. Well, when you add angles 2 and 5 together, you have 90 minus k plus k, which equals 90. Your answer will actually be 90 degrees. So what that tells us is no matter what value I would have picked for 1 here, I would have came out with 90 here. If I would have said this was 23.5, this still would have been 90 over here. Do those steps all make sense? It's a little confusing. All right, other questions? Okay, cool. Let's go through today's lesson then. get to it. All right, today, remember that postulate you were clamoring to use that one day because you're like, it would have made it so much easier? Yeah, you too. We can now use it after today. And that is your angle, side postulate. It is on your pink sheet. It is that fourth one that is on that sheet. So currently we have side, 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 angle, side, angle, and angle, side. Why is that important? If you look at all of them, there's only two possibilities that don't work. There's only two that don't work, and that is angle, and side, angle. Those are the only two ways you could set things up that wouldn't work. Everything else will work. So once again, angle, and side, angle won't work. I remember side, angle because if you spell it the wrong way, you get a non-approved BA word. If it's not an approved BA word, then you can't use it in this class. Not a joke, just a way to remember it. All right, so we're talking angle, side postulate. If two angles and a non-included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Note, angle, side. Angle, side. That is the last one. We can now use angle, side. All right. I don't think I put any other notes on there, no. Because we talked enough about all of them. All right, so we're going to prove that two triangles are congruent. We're going to prove that two triangles are congruent. So it doesn't even tell us what triangles we're proving. It gives you a mystery is congruent to a mystery. So in these cases, the best thing to do is take your given, draw it, and see what triangles you can prove are congruent after that. So our two statements are our first one is angle T is congruent to angle S. Let's go ahead and draw that. Angle T is congruent to angle S. And that was given to us. They gave us something else too. They said that RZ is perpendicular to TS. That was also given to me. That is something I should break down and say why that's important. Because each of these should have two elements that show me two things are congruent. So it says RZ is perpendicular to TS. What does that tell me about angle 3 and angle 4? What does that tell me about angle 3 and angle 4? Alicia? They're congruent. So we can go ahead and say that angle 3 is congruent to angle 4. And can someone give me the postulate or theorem that allows me to go, hey, if I have a perpendicular line, the two angles it creates are congruent. We do have a theorem or a postulate that says that. Jacob?
Theorem 2.
It is theorem 2 that lets you say that. If you don't know where theorem 2 is or what it says, you should be looking at your sheet right now. Krupa.
Could you use the definition?
The definition of perpendicular lines would say that angle 3 equals 90 degrees and angle 4 equals 90 degrees. That's the definition says. So we could use it, but then we need one more step saying they're congruent then. Our theorem 2 goes right to just saying, without saying they're 90 degrees, it says we can go straight to them being congruent. So Krupa, if you didn't remember theorem 2 and you went your way, full points. It just might be an extra step. All right. All right, so we have theorem 2. So we have angle 3 and angle 4 are congruent. Angle 3 and angle 4 are congruent. Remember, if I'm saying two new lines, I'm going to put two arcs on it. Can we already picture which two triangles we're trying to prove are congruent? I hope so. I hope so. We should be looking at this top triangle and this bottom triangle. Well, they gave me two angles, so I'm probably not going to use side, side, side. I'm probably not going to use side, angle, side, because I don't have any sides right now. So we're looking at either angle, side, angle, or angle, angle, side. For angle, side, angle, I would have to show that TZ is congruent to ZS. For angle, angle, side, I have to prove that RZ equals RZ. Which one seems doable? Which one seems doable? Sangha? And why does RZ equal RZ? Reflexive. RZ is congruent to RZ, and that is going to be our reflexive. Can someone tell me my next step? I have one more step. What is my next step?
Angle RTC is congruent to the triangle RC by angle.
Did you say it like that? I don't know if I got the... Did I get the order correct that you said?
Yeah.
EJ.
Couldn't you have done it the other way with the isosceles triangle theorem converse, so that RT
No.
S? No.
Oh, yeah, you could.
Yeah.
Yeah, I'm sorry. Yeah, yep, you could. So what EJ said is, I thought you were saying because these two, I'm like, those aren't congruent. I see what you mean. So EJ was saying, see how angle T and angle S are congruent? We could then say the sides opposite, which would be RT and RS are congruent. That would have been another way to get angle side, right? Perfect. Yeah, that's awesome. There are some proofs that actually need that.
Okay.
So once again, EJ noticed that the side opposite T would have to be congruent to the side opposite S by the isosceles triangle converse. Jacob.
Okay. No, never mind. Sorry. I didn't know if it was the converse.
Oh, it's the converse. The converse always starts with angles and leads to sides. The theorem will always give you sides and go. And the way I remember that is the theorem is based upon an isosceles triangle having two congruent sides.
Okay.
That's what it means to be isosceles. So the converse is it also has base angles congruent. All right, so we have two triangles congruent. And that is going to be because of angle side. So just a quick recap. EJ said there's an alternative. You could also have done 3 is RT is congruent to RS by the isosceles converse. All right, so that's just an alternative way for 3, and you get the exact same answer. As always, there's always multiple, most of the time there's multiple ways to do proofs. Some are better than others. This is the exact same amount of effort. Either one of these is the exact same amount of effort. Questions on that? Okay. You don't know what triangles you are trying to prove until you actually start working on it and you start drawing them. We're not actually doing a proof here, because in fact the proof is pretty much done for us. We need to prove that GHJ is congruent to triangle GIK. What can help on problems like this is to redraw your triangles. So in that second box, I'm going to redraw those triangles as 2 separate triangles. So I'm going to draw basically GJH, and then I'll draw the other triangle that's in there, and that is that GKI. Then I'm going to put the information that's already in the drawing. It says that angle H and I are congruent, so let's draw those in there. Then it says that GJ, I don't know if I had a hard time saying that, but GJ is congruent to GK. And we know one more bit of information. We actually know one more bit of information. And it relates to, remember we said RZ equals RZ by reflexive? Look at angle G. This angle G is the exact same thing as that angle G. So in fact, that would be our entire proof then. I would just say G is congruent to G, and maybe I will put it down there. Maybe I'll say angle G is congruent to angle G, and that would be reflexive. And now we just have angle side. So we actually just did a proof there, Emma.
Could you do a side angle side? Because you have two. Oh wait, no.
We already have two congruent sides. Those are the only ones that we know for sure are congruent sides.
Okay, yeah, I see.
Because none of the other ones are reflexive. They don't meet up with the whole thing. So,
Can I ask what F is?
yes. Same thing. Krupa.
So when you give it to us like this, we have to dry it out.
If you don't have to, you don't. But it can really help you on these, especially if you're really struggling on it. All right, and drawing it, I'll get you more points if you made like horrible mistakes in the proof. Does that make sense?
Yeah.
Okay. So like our first proof example, you may not need to redraw the triangles, but it can really help when you're doing this. So we're trying to draw that ABC is congruent to, well, it must be that other triangle. So I am going to redraw them, but some of you won't have to. It depends on how good you are spatially. Sometimes spatially wise, some people can see both triangles and they both just appear and everything jumps out to them. Other people, you have to redraw it so you can see the elements on display, I guess would be the best way to put it. So I'm going to split that into two triangles. I'm going to split it into A, B, C, and then my other triangle would be that DCB. And in fact, that could help you already know what triangles you're proving just by redrawing it. All right. Then we'll write down our statements. Statement number 1 was AB is congruent to DC. Once again, that was my given. So you're going to write down AB is congruent to DC. So AB is on my left-hand side. DC is over there. Then my next given was angle ABC is congruent to angle DCB. That once again was given, so let's draw that in there. ABC is this angle here, and DCB is this angle here. And those were all given. Anyone want to take a shot at what our next step is? I have side, I have an angle. I'm either looking for another side or another angle. Jacob.
BC is congruent to BC
Why?
because it's reflexive.
Reflexive. Do we all see that BC is congruent to BC? Even though I split them up here, they're still the same line. It's both BC. So our next step would just be BC is congruent to BC. That is reflexive. So we have BC. I'm putting 2 tick marks on both of them. BC is equal to BC. Can someone tell me what my last step is? And I'm going to start writing it with 3. What is my third step in this proof? Emma? Yeah, because of side angle side. So Krupa, to go back to your question, would I draw both these triangles? Maybe not.
Yeah, I like highlight.
Yeah, highlighting them is a really good idea. I have tons of colored pencils and markers and stuff. So either highlight them, be able to picture them. When you get to really complicated ones, those are the ones that might be a little easier to draw, or definitely highlight. Yeah, highlighting is a really good technique in these. All right, these are probably, these are, however you want to split it, probably the hardest proofs we have in this section. Because you are given bits of information, you have to figure out what triangle they're talking about, and then using that, you have to come up with that third bit of information. But remember, these work just like all the other ones. They're going to give you 2 equality statements, either 2 angles being congruent, 2 sides being congruent, or a side and an angle being congruent. Your job is always to just find that third piece of information. I'm trying to see if there's any standout as super difficult. Number 6, I changed it a little bit. none of them should be super, super difficult. All right, they are just like I said. They give you a couple pieces of information. You have to come up with the third one, or in some cases, you don't have to come up with any. They might actually give you everything you need to prove they're congruent, and you have to do one step further. All right, the rest of the time is you.